Welcome to The Explainer. So today we're diving into a biological mystery that's completely redefining how we think about human lifespan. For generations, we've thought of aging as this single, unstoppable march of time that affects our entire body equally. But what if I told you your body doesn't actually age all at once? What if your organs are all ticking on their own, completely distinct biological clocks? It's a fascinating concept, and the cutting-edge science we're going to unpack today proves that we're so much more complex than just a single number on a calendar.
Okay, picture this strange but highly realistic scenario. Imagine you pull out your birth certificate and it says you're 45 years old, right? That's your chronological age. But what if we could look under the hood? What if a biological readout showed that your heart is actually functioning like it's 60, while your kidneys are operating like they're 30? Scientists are calling this the mosaic concept of aging. You aren't just one age, you're a mosaic of a bunch of different ages internally, with some organs literally sprinting toward the finish line way faster than others.
Here's our quick roadmap for today. We'll dismantle the myth of uniform aging, unlock the proteomic clock, uncover how it acts as a hidden disease predictor, explore tailored interventions, and finally, look at how to resync your body.
All right, jumping into Section 1, the myth of uniform aging.
To really grasp modern longevity science, we kind of have to unlearn something we've believed for centuries. We need to look at the stark contrast between chronological age, that single number on your birth certificate, and biological age. Think of your body like a fleet of cars that were all bought on the exact same day, but driven completely differently. Your lungs, your liver, your brain, they're all dealing with different levels of stress, different genetics, and different environments. And because of that, they age at entirely different speeds.
Moving right along to Section 2, unlocking the proteomic clock. So, if our organs are aging differently, how do we actually measure them without doing invasive surgeries? The secret is in our blood, through a really cool field called proteomics. Now, for decades, standard medicine basically just used blood tests to look for signs of injury. Like if you had a suspected heart attack, doctors would check for specific heart proteins that spill out during trauma. But proteomics takes this thousands of steps further. It's the study of proteins naturally circulating in the blood that act as a direct molecular readout. So instead of just looking for damage, modern proteomics lets us literally listen in on the molecular chatter of the brain, the lungs, the liver, as they just go about their daily business.
11,000. That is a massive number. That's how many different proteins researchers like Dr. Tony Wyss-Coray and his team at Stanford can now measure. And honestly, the most mind-blowing part, they can measure all 11,000 of those proteins in just a single tiny drop of blood.
And since many of these 11,000 proteins come from highly specific places in the body, they're basically unique biological fingerprints. From that one single drop of blood, scientists can run the data through advanced algorithms to build proteomic clocks. These clocks give us this incredibly detailed map estimating the biological age of 40 distinct cell types throughout your body. So we're no longer just guessing how healthy your internal systems are, we actually have a high-definition localized map.
Now here's where this data totally flips our understanding of the aging timeline. We always thought aging was just a slow, steady decline, right? Just a gradual downward slope. But proteomics reveals that aging actually happens in massive biological waves. The makeup of our blood-borne proteins shifts dramatically at three very specific points in our lives, around age 35, again in our early 60s, and then in our late 70s. So it's not a slow leak, it's a series of sudden structural shifts in how our body operates.
Which brings us to Section 3, the hidden disease predictor.
Now that we know we can measure these clocks, why is it such a big deal? Well, it all comes down to a vital concept called the age gap. The age gap is simply the mathematical difference between your chronological age, that birth certificate number, and the estimated biological age of a specific organ. Finding an outlier organ, meaning an organ with a massive age gap compared to the rest of your body, is turning out to be one of the strongest, most accurate predictors of future disease known to modern science.
To put that into perspective, let's look at what this means in reality. If your proteomic clock shows your heart is aging proportionally with the rest of your body, you sit at a baseline, 1x risk for heart disease. But if you have a fast-aging heart, meaning there's a significant age gap where your heart is biologically way older than you are chronologically, your risk for a cardiovascular event absolutely skyrockets by a 2.7x multiplier. That is a super sobering reality, especially because someone with a fast-aging heart might feel perfectly fine today. The breakdown is happening on a molecular level long before you ever feel a symptom.
And it's definitely not just the heart. This early warning system applies to our most complex organs too. An accelerated brain age gap,
where the proteomic chatter from brain cells looks older than the person's chronological age, is actually a powerful predictor of Alzheimer's disease. This molecular warming sign pops up years, sometimes literally decades, before any noticeable cognitive decline or memory loss happens. The predictive power here is absolutely staggering.
Let's pivot to some good news in Section 4, Tailored Aging Interventions.
Look, knowing you have a fast-aging organ sounds pretty terrifying if you can't do anything about it. But we're moving from just predictive data to actionable solutions. The old advice for longevity was always so generic and, frankly, unhelpful. Just live a healthy life, eat your vegetables, get some sleep. But the future of human optimization, driven by platforms like Vero Biosciences, is all about targeted interventions for your specific weak link. We're ditching the one-size-fits-all advice and stepping into an era of hyper-personalized protocols based exactly on which organ is sprinting too fast.
So, how does this play out as an actual strategy? Different weak links require completely different protocols. If your proteomic test shows your heart is the outlier, your fix isn't just general movement. It needs to be specific. An increase in aerobic exercise and high-intensity intervals designed specifically to boost cardiorespiratory fitness. But actually, scratch that if your liver is the fast-aging outlier. Hitting the treadmill for hours isn't going to be the most efficient fix there. Instead, the intervention would heavily focus on reversing insulin resistance through intermittent fasting and targeting visceral fat reduction. The intervention absolutely has to match the organ.
All right, our final stop, Section 5, Resyncing your body.
So how do we get these organs back on the same biological clock? Well, it turns out they can actively communicate with and heal one another. When you exercise, you're placing a controlled physical stress on your body. In response to that stress, your liver springs into action and dumps a specific protein called clusterin into your bloodstream. That clusterin then travels all the way up to your brain, crosses in, and gets right to work reducing neuroinflammation and improving cognitive function. By simply moving your body, you're basically commanding your liver to send a molecular stay young signal directly to your brain. It's wild. It proves our organs are this highly connected, interactive network.
And exercise isn't the only way to trigger these signals. By choosing the right stressors, we can force our outlier organs to resync. Deliberate heat exposure, like jumping in a sauna, activates heat shock proteins that protect your cells. Certain lifestyle factors can activate the FOXO3 gene, which upregulates DNA repair pathways. And specific resistance training sends its own totally unique cascade of anti-aging proteins throughout the body. We literally have the tools to pull the levers of our own biology.
So the absolute crucial point I want you to take away from this explainer is this idea right here. Move from reactive medicine to proactive prevention. The ultimate goal of mapping the proteomic pulse isn't just about extending your lifespan, it's about maximizing your health span. It's about making sure every single organ in your body stays at peak function for as long as possible. By leveraging this data, you stop waiting for things to break and you become a scientist of one, optimizing your internal mosaic way before disease ever has a chance to take root.
I'm going to leave you with this final, provocative thought. Have you ever taken a biological age test to find your body's weak links? Just imagine what you could do if you knew exactly which organ was begging for attention. Would having that kind of localized data totally change how you approach your diet, your fitness routine, or even your sleep habits? Think about it, and please let us know in the comments how you would use this data. Knowledge is power, for sure, especially when it comes to your own biology. Keep exploring, stay curious, and keep learning.